Hello and welcome back. In this video, we're going to enter into a new chapter, which is Chapter 3, Selection and Speciation. Once again, I'm Miss Delia, and if you're ready, let's continue. So this chapter is divided into two subtopics, which is 3.1 Selection and 3.2 Speciation. In this video, we're just going to go into 3.1, and as you can see here, we're going to be talking about lots of genetic and also phenotypic variety that we can see in a population and how that can be selected for. So enjoy this picture of a population of bunnies with lots of genetic diversity, and we're going to explore about the concept of selection. So yes, sometimes nature picks what it wants. These are the learning outcomes for this subtopic. I hope that by the end of the lesson, you would be able to define natural selection, state the three types of natural selection, analyze those three types of natural selection, define what is artificial selection, and also describe inbreeding and outbreeding selections. Now, here is a chart that is a very quick overview of the concept that we'll have in this subtopic. So under selection, we have natural and artificial, and we'll learn about the types of selection under each of these categories. But before we go and explore more, let's give a definition of selection. Selection is a process that will select or choose individuals with advantageous inherited traits to survive and reproduce at higher rates. So, di adalah proses memilih individu yang ada ciri-ciri yang membolehkan dia untuk hidup ataupun survive dengan lebih bagus pada kadar survive dengan lebih bagus dan membiak pada kadar yang lebih tinggi. Advantageous inherited traits means that these good traits must be something that has a genetic basis. It can be inherited to the next generation. There are two types of selection, which is natural selection, and the second one is artificial selection. So let's talk about natural selection. This is a concept that you'll see a lot in evolutionary biology as well as talking about ecology. And basically, when you're learning about, big nature, natural selection is something that you'll come across quite often. We can use several definitions for the term natural selection. The first definition you can use is that natural selection is a process in which individuals that have certain heritable traits survive and reproduce at a higher rate than other individuals because of those traits. A second definition we can use is natural selection is the evolutionary process that occurs when a population is exposed to environmental factors that consistently cause individuals with certain heritable traits to have greater reproductive success than individuals with other heritable traits. Or you can also use this definition, which is my favorite. Natural selection is a process of selection whereby individuals which are better adapted will survive and produce more offspring or have better reproductive success. So, tiga-tiga definisi ini membawa maksud yang lebih kurang sama. In simpler terms, these individuals that are physically or behaviorally better adapted to the environment will survive and reproduce. Individu yang sama ada dia punya perwatakan dari segi fizikal ataupun dari segi tabiat dia, perbuatan dia, kalau ciri-ciri luaran ataupun perbuatan dia itu membolehkan dia survive, hidup dengan lebih baik di persekitaran tersebut, dia lebih banyak chance untuk hidup lah. And second point, the individuals which are not adapted to the environment will fail to survive and reproduce. So they die before reproducing. So the ones that can live in the environment, yang dapat hidup, dapat teruskan hidup, dia dapat teruskan membiak. Kalau dia dapat membiak, gene dia dapat dipas kepada generasi seterusnya. Kalau dia tidak dapat hidup, dia tidak dapat survive dalam persekitaran tersebut, dia akan mati sebelum dia sempat membiak. Jadi, dia kira macam lama-kelamaan, genetik dia semakin kurang lah. Okay, so that is the concept behind natural selection. You live long enough in that environment, you can make more babies. That is natural selection. There are three types of natural selection that you'll learn about. The first is stabilizing selection. The second is disruptive selection. And the third is directional selection. And we can usually see them represented in these kinds of graphs. So, setiap graph yang kamu akan tengok dari sekarang, dia akan start dengan satu normal graph of a normal original population. After stabilizing selection or disruptive selection or directional selection, the graph is going to change based on the frequency of those genotypes. Okay, so let's have a look at each of these types of natural selection. We'll have a look at the first one. The first is stabilizing selection. This is a selection that favors intermediate phenotypes. So, phenotype yang tengah-tengah itu, yang heterozygous, yang biasa banyak chance untuk hidup kalau dalam stabilizing selection. It will act against both extreme phenotypes. So, extreme phenotypes means the homozygous dominant and the homozygous recessive. The intermediate phenotypes have a greater survival and they will reproduce successfully. The extreme phenotypes of the population have a lesser chance to survive. Stabilizing selection will reduce genetic variability in the population. In other words, it causes there to be less variation in the population. An example that we will use is the human birth weight. The birth weight of most human babies will be between the range of 3 kilograms to 4 kilograms. For us human babies, average weight babies are more likely to survive. So around 3.5 kilogram, 3 kilogram, 4 kilogram, it's okay. You're gonna have a normal birth. If they're underweight babies, so maybe 3 kilograms or maybe 2.5 kilograms at birth, the process of giving birth to them is okay, but once they're out of the womb, they are more prone to illnesses, and if they don't survive the illness, they're not going to survive until childhood. Whereas for overweight babies, these are 4 kilograms and above, they are more prone to difficulties during childbirth. So if it's a normal birth, you can imagine how narrow is the cervix, and an overweight and large baby would have a difficult time being born as compared to the average weight babies. Which is why when we look at the graph for the birth weight and the percentage of births in population, we can see that most of the babies that are born will have their weight around the average range. And we also have another graph here. You can see the red line with the red dots. That is the percent of infant mortality. So yang warna merah itu adalah menunjukkan berapa persen daripada baby yang lahir pada berat ini, berapa persen daripada mereka akan meninggal. How many of them would not survive their infancy? So as you can see, the mortality rate for underweight babies is quite high. The mortality rate for overweight babies is not as high as the underweight ones, but still higher than the average weight babies. Tadi saya cakap 3 hingga 4 kilogram, graph ini adalah dalam pound. So make sure you take note of that difference in units. Okay, so we also have another example here. The second example that we can use for stabilizing selection is by taking the example of a lizard population. In this population of lizards, there are small-sized lizards that are unable to protect their territories. So this is one of the extreme phenotypes. So ini lizard ni dia terlampau kecil. So dia tidak dapat pertahankan kawasan dia sendiri. So dia tidak dapat pertahankan kawasan dia sendiri, dia tidak cukup makanan, dia tidak cukup pasangan untuk mengawan, dan pelan-pelan dia akan mati. There are also large-sized lizards that are easily caught by predators such as owls, which is an extreme phenotype. So di sini kita ada lizard yang lebih besar. Okay, dia dapat jaga kawasan sendiri, dia dapat cari makanan, dia dapat mengawan. Tapi, kalau ada burung hantu ataupun apa-apa predator, dia yang duluan dimakan. So, this extreme phenotype is also not gonna survive as well. But we also have these intermediate-sized lizards, which will survive because they can adapt well to the environmental conditions, but they're also not the first pick when predators come to eat. Okay, so ini yang tengah-tengah ini yang lebih banyak chance untuk hidup berbanding yang terlebih besar ataupun yang terlalu kecil. So this is an example of stabilizing selection in a lizard population. So once again, this is stabilizing selection. We are going to start with a population like this. Eventually, the variability will go down. Your graph becomes higher and narrower. Stabilizing selection, once again, reduces genetic variability. All right, so I'm going to move on to the second type of natural selection, which is disruptive selection. Disruptive selection disrupts, dia mengacau. It will favor both extreme phenotypes, but acts against the intermediate phenotypes. So yang paling gelap dan paling cerah, kalau kita cakap pasal warna, akan lebih menang. Tapi yang tengah-tengah, tidak terlalu cerah, tidak terlalu gelap, dia akan kurang advantage dia dalam persekitaran ni. The circumstances for disruptive selection is that both extreme phenotypes have a greater survival and reproductive success, but the intermediate phenotype will gradually decrease in number and may become extinct. So, yang on the extreme phenotype ini, dia akan semakin banyak anak yang ada extreme phenotype. Yang di tengah-tengah, intermediate, semakin kurang anak. Dan lama-kelamaan, dia mungkin menjadi pupus. This will occur when the environmental conditions are varied. It's not just like one thing happening in that environment, it's more than one factor. Here, two extreme distinct phenotypes will separate and two new species may form. Disruptive selection will promote genetic variability in that population. So we have an example here. This example is using the Galapagos finches. So finches are a type of birds. In the Galapagos Islands, there are different types of seeds and finches with different beaks. So you can go ahead and Google where are the Galapagos Islands. On those islands, there are many of these finches. Each of those islands, there are different types of seeds, and the finches there will have different beaks. There are hard and large seeds, which the finches with big beaks can feed on. There are soft and small seeds, which finches with small beaks can feed on. And there are also birds with medium-sized beaks, but they will be eliminated because it will be more difficult for them to feed on both types of seeds. So yang dia punya paruh besar, dia dapat makan benih yang besar dan keras. Kalau paruh dia kecil, dia boleh makan benih yang kecil. Okay, so those two have their own selection of food, but the medium-sized birds will have a hard time eating either the soft small or the large hard seeds. And just as a bonus, here are some pictures of those finches. On the left is the one with the small beaks, and on the right are the ones with the big beaks. Okay, so once again, just a very quick summary. That is disruptive selection. It will promote genetic variability, and over time, your original population graph will go and become like this. Dia dikacau, disrupted. All right, going to the third type of natural selection, it is directional selection. So directional selection is going to take the graph in one direction. It will favor one extreme phenotype. Salah satu phenotype saja yang akan ada advantage dalam persekitaran tersebut. It will act against the other extreme phenotype and the intermediate phenotypes. The circumstances for directional selection is that it will shift the curve towards the favored phenotype. So kalau original curve dia begini, dia akan pergi ke arah phenotype yang lebih digemari, lebih banyak advantage dalam persekitaran tersebut. And one extreme and intermediate phenotype will decrease. So this extreme phenotype and also the intermediate phenotype will decrease in number. This type of selection will reduce genetic variability in the population. So we have a very common example here. This is an example of peppered moths of Biston betularia. They are a very common and very popular example. Dia adalah kupu-kupu yang dia punya pattern macam ni. So dia ada macam bintik-bintik, ada yang warna hitam sikit, ada yang warna putih sikit, ada yang macam grey-grey. Okay, so if you remember what is the Industrial Revolution, that's when people discovered that they can do a lot of things with tin and metal and they start building a lot of factories. So after the Industrial Revolution, we have a lot of factories, like we have a lot of air pollution. Due to the coal-burning factories, the light-colored lichen, if you remember what is lichen, that's those things growing on trees. Because of the factory and the air pollution, the light-colored lichen on the trees will die. So no more white color. And the tree barks will become covered with soot. Sudah lah dia ada lichen untuk bagi dia nampak putih, dia ditutup lagi dengan abu-abu, like the soot, jelaga. And then that's gonna make the whole tree look even darker. When the tree bark is dark and black, intermediate phenotypes, like the light gray peppered moths with the little black spots, when it sits on the black trees, the birds can easily see them, so they are more likely to be eaten by the birds. The extreme phenotype, that is the very light colored, ini yang putih punya moths, they are more likely to be eaten by birds because they're going to be very obvious on the black tree bark. And the other extreme phenotype, the favored extreme phenotype, which is the black moths, when they sit on the black trees, they are able to blend in with the environment sebab hitam atas hitam. The birds will not be able to see them as clearly, and they are less likely to be eaten. So before the Industrial Revolution, the white and intermediate colored moths are going to be able to survive more. But after the Industrial Revolution, the black-colored moths are going to be able to survive better. So in this example, the directional selection is favoring the dark-colored moths. It is favoring one extreme phenotype. Hope that's clear. The next example is a bit more simple. This is just a very general one. The second example is we can take the thick fur of animals in cold climates. So if you imagine a very snowy landscape, it's very cold. There's no main sources of heat. In these cold climates, the individuals, or more specifically the mammals with the thickest fur, which is an extreme phenotype, will survive better because they have more insulation, they can adapt well to the cold weather, and they can survive longer, and they can reproduce more offspring. So this is a more simple example of directional selection. In the coming years, there will be more and more animals with thick fur in that cold climate. So yes, that is it. We had two examples for directional selection, and once again, directional selection is a selection that will reduce genetic variability and shift the graph towards one extreme phenotype. Woohoo! So that is it for the first part of selection. That was natural selection. So in this next part, we're going to be talking about the artificial ones. So artificial selection? Of course, let's start by defining what is artificial selection. Artificial selection is a process of altering the genotype and producing a new strain of organism for a specific purpose. It is the selective breeding of plants and animals to encourage the occurrence of desirable traits, and this leads to changes in genotypes of offspring, thus producing new varieties of organisms, which is our domesticated animals. Kalau natural selection adalah diperbuat dari hasil daripada nature, persekitaran secara semula jadi. Artificial selection pula adalah manusia pilih mana satu baka dia mau kasih campur atau kasih biak untuk hasilkan baka yang domesticated. So the domesticated animals or the crops that we grow will have the desired traits that we want. There are going to be two types of artificial selection, which is inbreeding and outbreeding. Enjoy this very cute picture of a pug, and then we're going to continue on with inbreeding, which is the first type of artificial selection. Inbreeding is involving mating between closely related individuals within one population. For example, inbreeding could be self-fertilization in plants, or it could be marriage between relatives or cousins. Inbreeding is an example of non-random mating. It will increase homozygosity, which is when genes become homozygous, and increase the chances of expression of recessive alleles. Inbreeding will show less variation, which is they will reduce genetic variation, and species may not be able to adapt to changes in the environment. Inbreeding will increase the chances for inbreeding depression, where the individuals will have lower fitness and survival. Examples of things you can see in an individual with inbreeding depression is the low ability to survive and reproduce, a shorter lifespan, they may be less fertile or not resistant to diseases. So, kalau dia kawin sesama sendiri, itu boleh kira sebagai contoh inbreeding. Boleh tengok di tumbuhan, boleh tengok di haiwan, boleh juga tengok dalam manusia. It's non-random, homozygosity. So, kita akan lebih banyak gene yang homozygous. Dan biasanya gene yang homozygous tu kadang-kadang lebih banyak yang recessive allele. And lebih sedikit variation dalam population selepas tu. Dan inbreeding depression ni adalah sesuatu yang kita patut ingat lah. So, more and more generations that you do inbreeding for, the offspring are going to become less and less suitable to survive on their own. Dia macam makin banyak kecacatan sebab dia terkumpul semua allele yang recessive, yang harmful. Okay, so let's have a look at a few examples. So we have the first example, which is a type of domesticated animal. We have Persian cats. If you have overly purebred Persian cats, they will produce offspring with faces that are so flat, it is prone to tear duct overflow, breathing, and sinus problems. So it looks cute, but they're going to have a lot of health problems because of the way their faces is structured. So on this one here, this orange one is a not too inbred Persian cat. But this one is excessive inbreeding and it has these very exaggerated features. Another example is we have the heavy inbreeding in Damascus goat. So over many generations of excessive inbreeding, this Damascus goat will have deformed facial bones. They will have an undershot jaw and a snub nose. So dia punya rahang bahagian bawah terlampau panjang, hidung dia terlampau pendek. And they're going to have a lower chance of survival in the wild. So that brings us to the end of inbreeding. So now we'll go into the second type of artificial selection, which is outbreeding. Outbreeding is the mating between unrelated or distantly related individuals of a species. So these are usually between individuals of different varieties of strains. The offspring produced from outbreeding are also known as hybrids. The outbreeding will show more variation, increase the number of heterozygous individuals, and also show hybrid vigor or heterosis. Hybrid vigor or heterosis is when the hybrids possess good or high quality traits, such as early maturation period and increased fruit. They would have increased fruit size and number if they're plants, and if whether they're plants or animals, they could also have increased resistance to disease. Kalau ini kita boleh kira dia sebagai kawin campur ataupun yeah, that's practically what it is, isn't it? Outbreeding is kawin campur. And then hybrids, kalau kita mau translate kepada bahasa biasa, dia lebih kepada kacukan. Okay, and you can see some people talking about this in humans as well, kalau orang manusia kawin campur. Tapi itu bukan topik yang saya akan bincang dalam video inilah. Kita cuma akan discuss pasal outbreeding dalam haiwan. Okay, so usually the kacukan will have better traits. So we'll have a few examples here. I have some examples of cattle and sheep. So we have the Hereford and Aberdeen Angus, which are bred to produce high quality and high quantity of meat. You can have the Hereford and Aberdeen and you crossbreed them to produce this hybrid breed. You could also breed cattle that are able to give high yield, higher quantity of milk. So the Jersey and the Guernsey cows are bred to yield that high quantity of milk. And one thing I didn't have the pictures for here are the Hampshire and Suffolk sheep, which are bred to produce high quality of meat, specifically mutton meat. Outbreeding is not just for animals. We can also do that with plants. Of course, I'm sure you can think of a lot of plants, especially if you're used to buying them or growing them in your family yourselves. But the example that I will have here is for oil palm. So here in the oil palm industry, we have Palm piscifera and Palm dura. The modern oil palm tree, Guineensis, has three fruit forms, which is dura, thick shell, Piscifera, shellless, and Tenera. The Tenera palm yields far more oil than Dura and is the basis for commercial palm oil production in all of Southeast Asia. So you can see here, we started with the Piscifera, and the Dura varieties, but then we crossbreed them and we produce the hybrid oil palm Tenera. And this is the one that we use in a lot of agriculture, not only in our country, but also throughout Southeast Asia. So this will produce oil palm fruits that have high oil content, and the fruits also do not drop easily. So there are a few advantages to outbreeding in case you haven't noticed. The progeny or the offspring of outbred individuals will have better adaptation to environmental changes. So dia dapat lebih mudah untuk sesuaikan diri kepada perubahan alam sekitar. They will have increased resistance to disease. They're less likely to die from being sick. They also show more variation or increased variation, and it can increase the number of heterozygous individuals. And usually, the progeny or hybrids can have new superior or high quality phenotypes, which is also referred to as hybrid vigor or heterosis. So if people ask you what are the advantages of outbreeding, you can use these examples here. So of course, we can compare between natural and artificial selection. You can compare them here. You can compare them in terms of the selection agent, whether it's random or planned, how are the selected varieties, what is the result of the varieties, does it occur naturally in natural populations or does it only occur in domestic populations, and is it a fast or slow process. So these are some ways where you can differentiate between natural and artificial selection. And that brings me to the end of 3.1. So far in this chapter, we have gone through one subtopic where we talk about natural, artificial selection, and also the 3 types of natural selection and the 2 types of artificial selection. I hope that you'll be able to remember them and also answer questions about them when you see them during UPS or in the exam. So, what should you do now? Well, come up with your own notes, of course, and then after you're done making your own notes, please answer the tutorial questions for Chapter 3, Part B, Question 1, and we'll discuss them when we have the tutorial discussion. That's all for this lesson. Thank you very much, and I'll see you again in the next one. Bye!